Welcome. This tutorial about vector calculus. So these would be again in the FE exam, simple and easy problems. Yeah. So here in this problem, it's asking you what is the, let's just read it carefully. Yeah. What is the direction of the gradient vector of this function below? So I'm asking you what is the direction of the gradient vector, yeah? And then what is the direction of the line passing through this with the maximum slope? Yeah, so basically, so you have this guy, you gradient, that's the path of the maximum slope, but here I'm telling you that this path, so like you have this path at a point, yeah? And then at this point, yeah, what is what is the gradient at this point, and then what is the magnitude of this gradient. Yeah. So basically here it tells you like the magnitude and direction, but here I'm just like asking you the magnitude. Yeah. So let's do it. Yeah. So like let's put our function here. So here our function f of x z is equal 5x squared minus 4y plus 6z plus 3xy. Yeah. And I'm looking for the gradient of this function. Yeah. So the gradient of this function, remember what's the gradient? So the gradient, that's like a vector. So this guy like is a vector. This guy is scalar, and I should expect like to get a vector. So I should expect to get something in the I here and something in the J here and something in the K here. So plus plus. Okay, so with respect to I, so here I have 10x, like from here, from this guy. Did I copy? Is this correct? Because again, one of the most common mistake in homework and exam is copying mistakes. Yeah, you do a copying mistakes. Well, this is not an uncommon mistake, like you copy something wrong. So okay, so here plus, what do we have here? 3y. Okay, in the I direction. And then what do we have in the J direction? So in the J direction, that's a constant, so this is 0. Here I have like minus 8y. That's a constant. And I have here plus 3x. Okay. And in the K directions, this is a constant. So here, oh, this guy, that's a constant. Yeah. Uh, this guy, that's a constant. Here I get like a 6. And this guy here, that's a constant. Okay. So I ended up with this equation that you see here. That's my gradient. So the gradient of this function is something that looks like this. Now I want to evaluate this gradient at a point. So like the gradient of the function at 1, -2, and 0. Yeah. So basically that would be like 10 times 1, that's like 10, plus 3 times -2, that is -6, and that is in the I direction, plus -8 times -2, that is 16, yeah, and then 3 times 1, that is 6, and that is in the J direction, plus 6k. So that will give me what? So that will give me 4 in the I direction, plus sorry, see, that's like not a copying mistake, that's just like a careless mistake. 3 times 1, that is 3, yeah, plus 19 in the j direction. Forgot to put the hat here to indicate that this is a vector. Forgot to put the hat here, plus 6 in the k direction. Okay. Yeah, so that's basically the gradient at this point. Now, what is the magnitude of the gradient, like the steepest ascent? Like, so the magnitude of this gradient, yeah, the steepest ascent of f. And here you don't need to put this because this is understood that this is a vector, but I just put it for, don't need to put it. Okay, so that would be 4 square plus 19 square plus 6 square. Okay, and then if you use your calculator, you will, this is correct, you should get something that looks like this, yeah. So you can do it and, I don't know, you should get something that looks like this. Okay. So this is like gradient, the divergence of a vector field. So what does the divergence do? So the divergence, it takes like a vector function. So like, see this guy here is like bold font, means that this is a vector. So this guy is a vector. And like we know that this guy is a vector, and the dot product of two vectors, you get a scalar. So basically, that's what you do. So it's telling you here, a wind tunnel experiment measure airflow around an object. The vector field below represents the velocity distribution of the airflow. So that's like the velocity, the I direction and the J direction and the K direction. Is like I'm asking you here, is the point like, so you have like in this field, is the point in the field source or sink? So how would you know that this is the source or the sink? So basically you just find the divergence at this point, and then once you find the divergence at this point, what do you do? When you find the divergence at this point, you just substitute, like, sorry, find the divergence of this function, you evaluate it at this point. If it's positive, it's a source. If it's negative, it is negative. It's a positive divergence. This means it's a source. So if you got a positive source indicating region where air is spreading out, source versus negative indicating is converging. Is converging. Okay, so let's just like do it. So let's type our function here. So this is our function, f of x, y, z is equal to x squared, okay, y is the I direction plus yz square the j direction plus x to z and the k direction. Yeah. Okay. So basically that is what you get here. Yeah. So like, what is the divergence of my function? Okay. So that is with respect to x plus your f2 with respect to y plus f3 with respect to z. So let's do it. Yeah. So this diversion is f2 with respect to x. Like, what do you get here? So you get like 2xy. And and then plus f2 with respect to y. So what do you get here? You get like z square plus f3 here with respect to z. So what do you get here? You got like x square. So you get this function that looks something like this. Yeah. Okay, so now I want to evaluate this. This is Okay, this is a typo here. This is a mistake here. That is not, this is a scalar. This is not a vector. This is like a scalar. This is not a vector. So again, there's a mistake here. Uh, no, actually, this is correct because this is a diversion of a vector function. Yes, so this is correct. Yeah, this is correct. Sorry, this is correct. Yeah, because this is a divergence. This is a vector function. It gives you a scalar. That's exactly correct because this is a vector and this is a vector. You get a scalar. Okay, but now I want to evaluate this guy at like 1, 2, and 3. Okay. So I want to evaluate this guy at 1, 2, and 3. So we got like 2, 1, and y is equal to 2 plus 3 to the power 2 plus 1 square. So if you did this, you got 4 here plus 9 here plus 1 here, then you should get whatever. Yeah, so this is 4 plus 9 plus 1, so that's equal to 14, which is larger than 1. So this is a positive diversion. So this is positive diversion, means it's like a source. Okay. Uh, Homework, I mean similar. So this homework I'm asking you also, is this like a source or like sink? And again, like how to do this, you just like do this guy, you do this guy, you do this guy, you do this guy, you evaluate it at a point, so you evaluate like the version of your h at like 2, 1, minus 3. Then if you got like a positive number, that would be like a source. If you got like a negative, that would be a sink. Yeah. Okay, so let's go to this conceptual question here. In vector calculus, the car vector is a vector, yes, that describes the rotation at each point in the field. What do you think? Is this true or not? Okay, so yes, that's exactly what the curl is. So, so this guy is correct. Yeah, let's not look here. A scalar representing the magnitude is not a scalar. We know it's a vector. Yeah, because it is like a vector cross product with another vector, you get a vector. Scalar representing the magnitude of rotation of the vector field at a point. No, it's not. This is not true because we know that, like here, we know that the fundamental uh, nature of curve is that like it measures rotations. That's the fundamental nature of curve. But here, this statement is uh, is not correct. Like the second statement here is not correct because it does not only point to like the magnitude of rotation, but also to like the direction. Yeah, the direction of the, so it tells you like the strength of the location and like the direction. So we know that this guy is not correct. A vector that point in the direction of the axis of rotation with magnitude indicating the strength of rotation. Yes, yes, that's exactly what it does. So it is a vector that points in the direction of the axis of rotation with the magnitude indicating the strength of rotation. So that's why this one is wrong, but this one is true. Scalar that indicates the divergent vector field at a point. So we know that this is wrong. So let's see here. A only, no. Number 3 only, no. 1 and 3, yes. 2 and 4. No. So the correct answer here will be C. Okay. Conceptual question. The diversion of a vector field. So that's your homework, yeah. And so let's see this. A scalar, yes, that represents the rate of which quantity expand or contract at a point in the field. Yes, source or sink. A vector that points in the direction of the maximum increase in the field. It's not a vector, it's a scalar. Scalar, so this is correct, that measures the net flow of a vector field out or into a point. Sources and sink, yes. A vector that describes the rotational tendency of a field at a point. That's the car. So number 1 alone only, number 3 only, this guy, this guy. So basically it is this guy. Yeah, that's like the answer of your homework. Okay, so I think that's all for this tutorial, and